Okay, we are going over midpoints of a parallelogram. Okay, the question asks us to verify that quadrilateral EFGH formed by joining the midpoints of adjacent sides of ABCD is a parallelogram. So, with that explanation, what they're saying is these midpoints, we'll call this E, F, G, and H, are a quadrilateral that is formed by getting the midpoints of A, B, C, and D. Okay? So the quadrilateral in black is ABCD, and the one in red is EFGH. We have to prove that EFGH is a parallelogram. Now, they've actually given us the coordinates, so I'm going to quickly read them out. A is 1 and 5. D is 7 and negative 3. Okay. C is 2 and negative 5. And finally, B is negative 4 and positive 2. So those are A, B, C, D. We don't know the measurements or the coordinates of E, F, G, H. So we need to find each of these midpoints, starting with E, F, G, H. And then to prove that it's a parallelogram, what do we need to find? What does parallelogram mean? The slopes. So I would have to prove, in order for this to be a parallelogram, that EF is parallel to HG and that EH is parallel to FG. Okay? So the first thing we'll do is find these coordinates, then we'll find the slopes of the lines they create to see if they're the same. So, very first thing we're going to need to do, in order to find midpoint, we'll write that formula down just once at the beginning. We know our midpoint formula is xm, ym, which is equal to adding the two x values together, so we'll call it x1 plus x2, dividing them by 2, and then the second part of the formula is doing the exact same thing with the y's. Whether they're y2's first or y1's first doesn't actually make a very large difference. So, we'll take the very first coordinate, we're going to do AB. Okay? AB, coordinate A was at 1 and 5, and coordinate B was at negative 4 and 2. We're going to plug this in very quickly over here, okay? Because we're going to have to do this 4 times to find the midpoints. So the two x values are 1 and negative 4, so I'm going to add them. Negative 4 plus 1, technically it doesn't matter the order, divided by 2. And we'll add the two y values, which are 5 and 2, so we have 2 plus 5 divided by 2. Negative 4 plus 1 gives us what? Negative 3. What's negative 3 divided by 2? Negative 1.5. Good. And 2 plus 5 is divided by 2? 3.5. That is our first midpoint, which we had. It's the midpoint of AB, so that is our coordinate E. Okay? So this is E for us. What we'll do, instead of writing this in, we're going to actually write the coordinates we're finding. So the next one we're going to look for is F, and F deals with B and C. So I'm going to write down, since we have coordinate B already, let's write coordinate C over here, 2 and negative 5. This will help us find midpoint F. Instead of rewriting the formula, I'm just going to go on the assumption that you guys understand that part, and we're going to plug our values in. So the two x values, which are negative 4 and 2, we add them, negative 4 plus 2, divided by 2. And the two y values, which are negative, or 2 and negative 5. So in this case, we have 2 plus negative 5, divided by 2. Negative 4 plus 2 gives us, divided by 2, negative 1. 2 plus negative 5 gives us negative 3 divided by 2, negative, good. So that's coordinate F. No, thank you. We found 2 of them to start. We're going to continue with this. We have EF. The next one we're going to look for is G. G deals with C and D. Okay, so I'm obviously going to have to write coordinate D just below here so we can see it. There's our coordinate D. So we're now working with C and D to find G. fit this all? Okay, good. Okay. So midpoint G is going to be equal to C and D. So we add the two C and D x values. That is 2 plus 7 divided by 2. And I'm going to speed this up. And our two y values are negative 3 and negative 5. So negative 3 plus negative 5 is the same as subtracting negative 5. Okay? 2 and 7 is 9, divided by 2 is 4.5. Negative 3 and negative 5 is negative 8, divided by 2 is negative 4. So there's our G. E, F, G. I think the last one's H. H is A and D. Good. So midpoint H, the last one we need to find. We said it was A and D. So again, let's add those x values. 7 and 1 divided by 2. And negative 3 and positive 5 divided by 2. So our final coordinate here, we really only need the coordinates. 8 divided by 2 is 4. Negative 3 plus 5 is 2. 2 divided by 2 is 1. So here are our coordinates. These are what's important to start. We found all of the midpoints, which are these values here. And now we need to find corresponding slopes. So we're going to recreate a very small diagram of what we had here. Let's assume it was some type of a rectangle-ish shape. I know it's not completely accurate, what it made. Wait, is that how it was made? Oh, no, sorry, it goes into a different shape. Okay, we're going to recreate it with lines instead. Delete. Okay, so we'll recreate what we had with lines here. It was something like this. We're going to find out if it creates a parallelogram. I know that's not perfectly drawn the scale. We're just trying to get an idea of where the points were. So let's say that this EF, oh, it's really poorly drawn. I'm going to try that one more time. How does it look? Looks like a diamond-ish shape. Okay. So I would say like this-ish. Okay, so we have our E, F, G, H. So our E starts at the top here. F, G, and H. And we have those coordinates written down right here. We've highlighted them. The question is asked, is this a parallelogram? So first thing we need to do is find the corresponding slopes of EF and HG. Okay, we'll do this in blue just so we know we're working with something different. Slope formula is, anyone remember? That was okay. A lot more mumbling than anything. y2 minus y1 divided by x2 minus x1. EF, these are the coordinates of E and F. We'll find the slope from that one, our very first one. So E and F. We're going to find the slope. So y2, well, I'm going to call this our y2, so negative 1.5. Subtract, here's our y1, 3.5. Divided by x2, negative 1. Subtract negative 1.5. Okay, remember we're subtracting a negative term, so we still keep that in there. Negative 1.5 minus 3.5. Anyone know? 1.5. Negative 5. And negative 1 subtract negative 1, 0.5. It's like adding those two values together. So we're going to have 0.5. Positive 0.5 on the bottom. Now, I'm going to divide these. Anyone know what this is going to become? Good. So the slope of EF is negative 10. We now have to find the slope of HG. HG being these coordinates here. Okay. We'll again use our slope formula. What I'm going to do is I'm just going to move over this one here so we have some room. Okay, we found EF. Let's find HG. HG. Y2 minus Y1. Well, I'm going to call... Wait a second. That should be an H. Let's make that clear. Okay, HG. Let's take those values. Our Y2, I'm going to call that this value here, which is 1, subtract negative 4. And then we're going to take our X2, which is 4, and subtract positive 4.5. Okay? 1 subtract negative 4, anyone know? 5. 4 subtract 4.5. Negative 0.5, which gives us what? It's the exact same thing we had before. Negative 10. So we know EF and HG were definitely parallel. The next pair we have to find are FG and EH and discover if they're parallel. So again, we find the slopes. If the slopes are the same, we have parallel. FG is the next one we have to do. Oh, that's kind of annoying. We're going to rewrite those at the bottom. We'll zoom out a little so we can see this better. Nope, zoom out a little more. Okay. Point F. FG will be the first one we work with. F is negative 1, negative 1.5. I'm not sure why it's doing that. We'll fix that after. And G is 4.5 and negative 4. We'll find the slope for these two to start. Very in-depth question. Okay, so those are 1. That's negative 1, negative 1.5. I don't know why it's still doing that. Okay, finding the slope. We'll take our Y2. We'll call that negative 4. And subtract Y1, which is negative 1.5. So subtract negative 1.5 divided by X2, which is 4.5. Subtract X1, which is negative 1. Okay. Negative 4, subtract negative 1.5. Anyone know? Negative 2.5. Good. And 4.5 subtract negative 1 is 5, positive 5.5. No thanks. Oh, what is happening? Oh, are you kidding me? Alright, fix that problem. Calculator, quick. What do we get here? Negative 2.5 divide 5.5.
Wait.
Negative 0.45? Okay. And let's check our other line, which is EH. So we're going to write those values again. Our E, where is E? E is negative 1.5 and 3.5. And our H is 4 and 1. So we're going to test those out. Hopefully that didn't screw up our calculation, that little thing we did. Okay, last time for slope. Let's quickly go through this. Y2, we'll call it 1. Subtract, positive 3.5. X2 is 4. Subtract negative 1.5. 1 subtract 3.5 gives us negative 2.5. And 4 subtract is like adding 5.5. We get what's considered the exact same slope as before. Okay? So, all that work just to prove that that is a parallelogram.